Welcome to the Deep Dive, your shortcut to being truly well-informed. Today, we're plunging into something that's, well, fundamentally changing how we interact with AI. Large language models, LLMs, you probably use them every day, maybe for emails, maybe generating content, and honestly, their capabilities are pretty impressive.
Oh, they absolutely are. But, despite how capable they seem, these LLMs, they run into two really significant hurdles.
Okay.
Think of it like this. An LLM's internal knowledge, it's like a giant library, but it's static. A snapshot from whenever it was trained.
Right, frozen in time, basically.
Exactly. So when it needs newer info or something outside that snapshot,
Yeah.
well, it can hallucinate.
Make things up.
Pretty much. It generates information that sounds plausible, perfectly fluent, but it's actually factually wrong because it just doesn't know.
Okay, that makes sense. Knowledge gaps or outdated info. So what's the other big challenge?
The second one is their struggle with genuinely complex reasoning. Imagine a real-world problem, something that needs multiple steps, logical leaps, maybe even a bit of creative thinking. LLMs often stumble there.
Even if they technically have the facts somewhere inside.
Yeah, even then. They might know the what, but struggle with the how to break down the problem, how to connect the dots thoughtfully.
So it's like one problem is not having the right information, and the other is not quite knowing how to think with the information they do have.
Precisely.
So what have people been doing to try and fix this?
Well, research has generally gone in two main directions. The first is retrieval augmented generation, RAG.
Right. Heard of that.
It basically gives the LLM access to external, up-to-date knowledge. Think of it like letting it browse the internet or a specific database.
So fixing the knowledge gap, what's the other direction?
That focuses on boosting their inherent reasoning skills, using techniques like chain of thought.
The think step-by-step idea.
Exactly. Encouraging the model to break down its reasoning process, making it more explicit and hopefully more logical.
Okay, so here's where it gets really interesting for you listening. These two issues, the missing knowledge and the, let's say, flawed reasoning, they aren't totally separate problems.
Not at all. They're actually deeply intertwined.
And that's our mission today. We're diving into a really groundbreaking survey paper. It's from researchers at Tsinghua University, University of Illinois Chicago, Peking University, among others. And this survey pulls together how the field is combining retrieval and reasoning. The goal, to create LLMs that are much more capable, more factual, and frankly, more intelligent.
We're talking about moving towards AI that can function almost like a genuine research assistant.
Exactly. So to really get this synergy, let's maybe quickly walk through the basics first, like traditional RAG.
Sure. So traditional RAG, it's usually seen as a three-stage pipeline. Pretty straightforward.
Okay, stage one.
Stage one is retrieval. The system goes out and fetches relevant documents or snippets from some external knowledge source, like a quick library lookup.
Got it.
Stage two is integration. It takes all that retrieved stuff, cleans it up, maybe removes duplicates, resolves conflicting info, ranks what's most relevant.
Like a librarian sorting the search results.
Precisely. And then stage three is generation. The LLM takes that curated context and reasons over it to produce the final answer.
And that's where something like chain of thought might come in, helping it process that information logically.
Exactly. Chain of thought often underpins that generation stage,
Yeah.
helping the LLM structure its reasoning, especially for complex questions. It makes the process more transparent and hopefully more accurate.
Okay. So initially, researchers tried to combine ARG and reasoning, but more like separate upgrades, like a one-way street.
Yeah, that's a good way to put it. There were sort of two main paths early on. One was reasoning-enhanced RAG.
So using reasoning to make RAG better.
Right. The idea was to use reasoning to optimize each step of that RAG pipeline we just talked about. The retrieval, the integration, the generation.
How would that work? Like reasoning to improve the search query?
Exactly. So instead of just asking a simple question, the LLM might use reasoning to break down a complex query into sub-questions, or rephrase something ambiguous, or maybe expand the query to get better hits. It's about smarter searching.
Okay. And for integration?
Reasoning could help assess relevance more deeply, filter out stuff that looks relevant but actually isn't, or synthesize information from multiple sources more coherently, making sure the final output is faithful to the retrieved facts and logically sound.
But I guess the risk there is if the LLM's initial reasoning is a bit off, it could retrieve the wrong stuff, right? Garbage in, garbage out, amplified.
Precisely. Shallow or flawed reasoning up front could derail the whole process, which leads to the other side of that coin, RAG-enhanced reasoning.
Okay, so flipping it around, using a RAG to make the reasoning better.
Exactly. Here, the focus was supplying external facts or context specifically to bolster the LLM's own thinking process, giving it solid ground to stand on.
So the LLM feels it needs a specific fact to solve a problem, and it goes and fetches just that.
Pretty much. Like retrieving specific factual entries for a question-answering task, or maybe formal lemmas if it's doing mathematical deduction.
Or legal precedents for a legal case, code examples for programming.
All of those. And it wasn't just static databases. This included web retrieval, too, accessing live dynamic info online for things like fact-checking current events.
Right, like some tools do now.
And also tool using, letting the LLM use external tools. Think calculators, financial APIs like Yahoo Finance, maybe even symbolic math tools like Wolfram Alpha.
To offload calculations or get specialized data it couldn't possibly store internally.
Exactly. Enhancing its precision, especially with numbers and specific factual lookups. There was even in-context retrieval, where models use their own past experiences or examples from training data to guide reasoning.
Okay, that all sounds quite powerful already. These one-way enhancements seem pretty smart. Why wasn't that enough? What were the big limitations of this retrieval then reasoning framework?
Well, despite those improvements, several critical issues kept popping up. The biggest one was probably retrieval adequacy. The knowledge retrieved before the reasoning started often just didn't match what the LLM actually needed as its reasoning unfolded.
Ah, okay. So it gets halfway through thinking about something complex and realizes, wait, I need a different piece of information now.
Exactly. But the standard retrieval then reasoning model couldn't really adapt. It had already done its retrieval.
It's like a detective given one batch of clues at the start of a case,
Right.
and then not being allowed to go look for more evidence later, even when their theory changes.
That's a perfect analogy. And related to that, errors or conflicts in that initial batch of retrieved knowledge could seriously mess up the subsequent reasoning. Bad data leads to bad conclusions.
Makes sense.
And fundamentally, the whole framework just wasn't adaptive. It lacked mechanisms for iterative feedback, for dynamic retrieval based on evolving needs. It was just retrieve, then reason, one shot.
Which isn't how complex problem solving usually works for us humans.
Not at all.
Okay, this brings us to the really exciting part then, the paradigm shift. Synergized RAG reasoning. What's the core idea here? This sounds like where things get really interesting.
Absolutely. The core idea is moving from that one-way street to a dynamic, iterative interplay. Reasoning actively guides the retrieval process.
Okay.
And the newly retrieved knowledge continuously informs and refines the reasoning process. It's a loop, a synergy.
So back to your detective analogy, the LLM is now thinking, realizing it needs a new clue, going out to find just that clue, bringing it back, and then continuing its investigation based on the new info.
Exactly. It's not just getting a pile of documents up front. It's an active, ongoing process of inquiry and integration. Thinking guides searching, searching informs thinking.
That feels like a much more intelligent way to operate, and you're saying we're already seeing this in action.
We are. Some of the cutting-edge, deep research features you see in products from places like OpenAI, Google Gemini, Perplexity.ai, they're built on this principle.
So these aren't just simple Q&A bots anymore.
No, far from it. These systems use what the paper calls agentic capabilities. They can orchestrate complex, multi-step web searches, interpret the content they find, synthesize information from diverse sources, basically tackle problems that require real, in-depth investigation. Much like a human researcher would plan and execute a research task.
Okay, so how does this synergy actually work under the hood? The paper talks about two main ways this manifests.
That's right. The survey frames it through two complementary perspectives. First, you have reasoning workflows. These are structured ways the LLM can think and explore, often involving multiple steps. Think of them as the how of the reasoning process.
In the second perspective,
That's agent orchestration. This describes who does what, how LLM agents, whether as one agent or many, interact with their environment, use tools, and coordinate the whole process.
got it. Workflows define the thinking patterns, and orchestration defines who executes those patterns. Let's dive into reasoning workflows first. How the LLMs think and explore. You mentioned chain of thought earlier. How does that evolve here?
It evolves into what are called chain-based workflows. These build directly on chain of thought, but crucially, they interleave retrieval operations between the reasoning steps.
Ah, so it's not just think, 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 retrieve, generate. It's think, retrieve, think, retrieve.
Exactly. Think step one, realize you need info, retrieve it. Think step 2, based on that info, realize you need more info, retrieve that, and so on.
Back to the detective again. At each stage of the investigation, they actively seek out new clues relevant to that specific stage.
Perfect analogy. It makes the whole process much more dynamic and targeted. Some methods even add verification steps, checking each reasoning step against retrieved evidence before moving on.
What are the upsides and downsides of this chain approach?
Well, the strengths are generally lower latency. It's fairly efficient because it's linear and is relatively easy to monitor what's happening. The main limitation is that if you make a mistake early on, maybe retrieve slightly wrong info, or make a faulty assumption in an early step, that error can easily propagate down the entire chain, and the context window can grow very large very quickly.
Right, one wrong turn early on can lead you way off track. So if linear chains have limits, what's next? You mentioned other workflows.
Right. The next level of complexity is tree-based workflows. These move beyond a single linear chain to explore branching logical pathways.
Branching, like exploring multiple possibilities at once.
Exactly. The best-known example is probably tree of thought, or 2T. Instead of just one line of reasoning, the LLM explicitly builds out a reasoning tree. It explores multiple potential paths or hypotheses simultaneously.
So if it hits a dead end on one branch, it can backtrack and explore another.
Precisely. It helps the LLM avoid getting stuck on an early mistake. It can compare different reasoning trajectories. There are variations too, like using Monte Carlo tree search to probabilistically guide the exploration, prioritizing more promising branches.
That sounds much more robust for complex problems where there isn't one obvious path. What's the trade-off?
The trade-off is typically computational cost. Exploring multiple branches means potentially many more reasoning steps and, crucially, many more retrieval calls. It can become quite expensive. And some methods, like the Monte Carlo ones, can require careful tuning.
More thorough, but potentially much slower and resource-intensive. Okay, so we have chains, we have trees. What's the third main type of workflow?
The third type is graph-based workflows. This is about structuring knowledge and the reasoning process itself like a network, using knowledge graphs.
Knowledge graphs. So where information is stored as entities and the relationships between them.
Exactly. Some methods involve essentially walking on an existing knowledge graph, aggregating information from connected nodes to answer a query. This is great for well-structured data.
Okay.
But perhaps more relevant to the synergy idea is something called think-on-graph. Here, the LLM dynamically uses a knowledge graph, almost like a reasoning playground.
A playground.
Yeah, it decides which entity or relationship in the graph to explore next, based on its current reasoning state. It gradually builds a path through the graph towards the answer.
So it's not just retrieving isolated facts, but actively navigating the structure of knowledge.
Precisely. It allows for very adaptive reasoning. And a huge benefit here is verifiability. Because you're working with graph nodes and edges, you can often trace the reasoning path very clearly and even provide citations down to the specific node or relationship level.
Wow, that sounds incredibly powerful for ensuring factual accuracy. What are the catches?
Well, the big one is you need a high-quality knowledge graph to begin with, which isn't always available, especially for very niche topics or rapidly evolving domains. It's less flexible for just querying the open web. And without good pruning strategies, the search space within the graph can still explode.
Okay, so chain, tree, graph, different ways for the LLM to structure its iterative thinking and searching. Now let's shift to the other perspective. Agent orchestration. This is the who does what part, right?
Exactly. How are these reasoning workflows actually carried out? Is it one AI brain doing everything, or is it a team effort?
Let's start simple. Single agent systems. One LLM runs the whole show.
Right. A single LLM is responsible for the entire process, decomposing the question, deciding when and what to retrieve, integrating the information, generating the intermediate thoughts, and producing the final answer.
How does one agent juggle all that?
Often, it's guided by clever prompting. Techniques like REACT, which stands for Reason and Act, explicitly prompt the LLM to alternate between internal reasoning steps, thought, and external actions. Action, search.
So the prompt itself structures the workflow.
Exactly. Or methods like self-ask, where the model learns to recursively ask itself sub-questions and then retrieve answers to them. Others, like self-RAG, allow the LLM to introspectively assess if it needs to retrieve information or if its internal knowledge is sufficient.
So it learns when to call for outside help. Are there other ways besides prompting?
Sure. You can use supervised fine-tuning, SFT, training the LLM on datasets that explicitly demonstrate this interlead searching and reasoning behavior. Toolformer is an example.
So training it on examples of how to do it right.
hmm And then there's reinforcement learning, RL. Here, you reward the agent for good search strategies and high-quality answers. Systems like WebGPT used RL to train agents to explore, gather evidence, synthesize it, and even self-correct.
RL sounds powerful for learning complex behaviors.
It is, but it's also computationally very expensive to train. The main strengths of single-agent systems are their relative simplicity and the fact that everything happens within one shared context. The limitations are that prompting can be brittle, SFT might overfit to the training data, and RL takes a lot of resources.
Which naturally leads us to multi-agent systems, dividing the labor.
Exactly. Instead of one LLM doing everything, you distribute the responsibilities among multiple, potentially specialized agents. Think of it like a research team.
Okay, how does that work? Do they all just work together?
Sometimes. In decentralized systems, you might have multiple agents collaborating. Perhaps one agent is good at retrieving text, another excels at image analysis, and a third focuses on synthesizing the findings. They work together to cover more ground and leverage their individual strengths.
Interesting. Like different specialists collaborating. What's the other structure?
The other is centralized or hierarchical. Here, there's more structure. You might have a manager agent that decomposes the main task,
Okay.
assigns subtasks to worker agents who might do the actual retrieval or initial reasoning, and then integrates their results. Or you might have agents organized in layers, refining the information as it moves up the hierarchy.
That sounds potentially very efficient for complex tasks, like a well-managed project team.
It can be.
Yeah.
The big strengths of multi-agent systems are potentially higher recall, covering more possibilities, better robustness, especially with noisy or diverse data, and efficiency through parallel work and specialization.
And I imagine coordinating all those agents isn't trivial.
Definitely not. The challenges include increased communication overhead. How do the agents talk effectively? How do they reach consensus if they disagree? Conflict resolution becomes more complex. And in centralized systems, the manager agent can become a bottleneck if it's not designed well.
So a lot of sophisticated ways to combine retrieval and reasoning. Stepping back, what does this all mean for you, the person interacting with AI? Why is this synergy so important?
Well, fundamentally, it's about making AI much more capable and reliable. We're moving away from models that just pattern match or sometimes confabulate towards systems that can genuinely investigate complex questions, ground their answers in evidence, and show their work.
Making them more accurate, more trustworthy.
Exactly. More efficient for complex tasks and ultimately better aligned with what users actually need when they ask difficult questions. It's about building AI you could actually rely on for more than just simple queries.
But it's not perfect yet. The survey also highlights some big challenges ahead, right? Where does the research need to go next?
Oh, absolutely. There are several key areas. First, reasoning efficiency. These synergized systems, especially the tree and graph ones, or multi-agent setups, can be slow.
Right, you mentioned a deep research query might take minutes.
Yeah, sometimes even longer. So future work needs to make the reasoning itself more efficient. Maybe developing ways for the LLM to know when enough reasoning has been done, or using more implicit, latent reasoning steps rather than making everything explicit. Strategic control over reasoning depth is key.
And tied to that must be retrieval efficiency. All those retrieval calls add up.
They certainly do. We need smarter retrieval. Things like budget-aware planning, only doing as much retrieval as needed or as resources allow, caching evidence effectively.
Yeah.
Maybe having the agent adapt its retrieval strategy based on its own uncertainty, retrieving more only when it knows it needs to.
Makes sense. What else?
A really important one is human-agent collaboration. How do we bring the human user into the loop more effectively?
So not just getting an answer, but guiding the process.
Exactly. We need systems where you can provide nuanced feedback to steer the reasoning, where the AI can understand your specific intent better, maybe adapt its strategy based on your level of expertise. Think truly interactive AI for tasks like systematic reviews or collaborative programming.
That sounds like a true partnership.
That's the goal. Then there's the development of the agentic structures and capabilities themselves, pushing towards more autonomous agents that can dynamically choose the right tools, plan complex retrieval and reasoning sequences, and manage the whole workflow with less hand-holding.
Getting smarter about managing themselves.
Right. Another huge frontier is multimodal retrieval and reasoning. Most systems we've talked about are primarily text-based.
But the world isn't just text.
Exactly. The future needs systems that can seamlessly retrieve, integrate, and reason over images, tables, audio, video, all sorts of content. This requires unified multimodal retrievers and much more sophisticated cross-modal reasoning abilities.
A massive challenge, I imagine.
It is. And finally, a crucial one, retrieval trustworthiness. If the AI is relying on external knowledge, how do we ensure that knowledge isn't biased, misleading, or even deliberately poisoned?
Right. The hallucination problem might be reduced, but what if the source itself is wrong?
Precisely. This involves looking at things like source verification, perhaps digital watermarking or fingerprinting, but also developing methods for the AI agent itself to assess the factual consistency of retrieved information, maybe even quantify its uncertainty about a source. Building trust is paramount.
Okay, so we've covered a lot of ground, from the basic problems with LLMs to these incredibly sophisticated synergized systems. Let's recap the big picture.
The big picture is this powerful vision of synergized RAG reasoning. We're moving towards LLMs that don't just generate text from static memory, but actively explore information, reason about it deeply, and potentially discover new insights by dynamically weaving together knowledge retrieval and complex thought processes.
And understanding this convergence, this synergy, is really crucial for anyone trying to grasp where AI is heading. This isn't just about slightly better chatbot.
Not at all. It's about pushing AI towards deeper understanding, more reliable problem solving, creating tools that can act as genuine research assistants, capable of tackling much harder questions.
So to leave you with something to think about, imagine an AI that doesn't just wait for your questions. Imagine one that learns how to ask better questions itself. And then it actively goes out into the world, the web, databases, maybe even connected sensors to find the answers, verifying them critically as it goes.
How might that kind of AI fundamentally change how you learn, how you work, how you discover new things? It's a profound shift to consider.